A very good evening, dear students. I hope you're all doing well. Roshit sir, good evening. Is my voice audible, sir?
Yes, good evening, Sushmita. Yes, audible.
Yeah, thank you, sir. You can start the session.
Okay, yeah. Students, give me 2 minutes. I'm setting up my whiteboard. Okay, very good evening, students. I see 100 as a participants here in the Zoom. Okay. Everyone chat is disabled. Yeah, it's working. Everyone chat is working. Good evening, Shubham. Good evening, Shrestha. Good evening, Pallavi. Good evening, Sangam. Good evening, Rakshita. Good evening, Sandhya. Good evening, Sravanti. Good evening, Sri Arshita. How are you all doing? How is your weekend went? Yes. Do you enjoy your weekend or you are practicing the DSA problems over the weekend? Is anyone doing that over the weekend? Did anyone practice the DSA problems? I'm curious to know. Did anyone did that? Okay, his assignment problems were done. I have given around three problems, right? In the last class. Those were done. Okay, time limited exceeded. Okay. So basically you are doing any brute force approach, I guess, for that particular question. See the constraints. You need to observe the constraints there. You're exceeding that constraint. What was said by that problem, that constraint you are exceeding by your brute force approach for the larger inputs. Okay, for the larger inputs, you are exceeding you are exceeding your code is exceeding the time. Okay, it is crossing that constant. What was the time that is been said? Because for every problem, for every problem, so every problem that you solve in real time, there will be some time complexity will be set up. Okay, either it should be max of big of n or max of big of n square. Okay, for larger inputs also it should be within this thing. Suppose I'm giving 1 million as range, also the input is, it should be within this range itself. The time complexity should be in this range itself. It should run for 1 million input also, within this range only it should run. If it is crossing n cube or some other things it is doing, like it is crossing the time limits, then in that case it will be time limit exceeded. You will get a time limit exceeded error. So single for loop, but arrays first, arrays dot sort. Yes, arrays dot sort, basically it in the backend the code is written using your kicksart. Okay, the code is written using your kicksart. The kicksart time complexity is big of n log n. Okay, n log n. So then your code again big of n. Okay, single for loop, but first arrays dot sort. Yeah. Okay, so let us revise from day 1 to day 5 what is being taught, and then we'll move with the today's agenda. Okay, so on day 1 we went with DSA discussion along with time complexity, space complexity, that logics we have discussed. Okay, so the notes is also shared, you can observe it. Okay, then on day 2 we went with the patterns coding, where is loops. Okay, loops with patterns coding. Okay, we have seen pyramid pattern, single full pyramid, off pyramid patterns, and then we have also seen butterfly patterns, and then we went with the number patterns as well. Like that, we have seen on the day, and on day three, we went with the arrays problems. Okay, we went with arrays versus array list, and then we went with the arrays like easy to medium level problems, right? So in that we have discussed move zeros to end, duplicates problem. Okay, duplicates problem. Removing duplicates also I have discussed. Removing duplicates as well as finding duplicates. Removing versus find. Okay, and then I went with subsequent sum as well, concept like subsequent majority sum, right? That is Cadanius algorithm, subsequent major sum. Okay, so these all problems we have discussed on the day, and on day four, what is discussed? I don't remember it. This is day five, right? Yes, on day four. Yeah, on day four, I have discussed this best time to buy, sell, and stock, remove duplicates from sorted array. And on day five, we went with the linear search, binary search, and then other things as well. Okay, so these are all the things we have discussed in the last week. Okay, so this week we will go ahead and do. We will start today. That is sorting problems. Okay, we'll discuss sorting algorithms. Okay, different sorting algorithms. Then we will go with the problems as well. Okay, then I will also discuss recursion along with problems. Okay, recursion and then problems, and then I will discuss linked list. Okay, linked list implementation, your linear data structure, that is linked list implementation in Java. Okay, in Java, basically we have a collection, right? Basically, we have a collection in Java where the linked list code is directly written. Your array list or your array list or your list interface, those are all nothing but your linked list only. It is based on your in linked list only it is been implemented. Okay, in the backend they have used the linked list implementation itself, doubly linked list implementation. Okay, we'll go ahead and discuss how we can manually implement this linked list in Java, and then we will discuss the standard problems that were there in linked list. Okay, and then we will go with stack implementation. Okay, stack implementation along with the standard problems. Okay, and then we will go with the queue implementation along with the standard problems. If time permits, I will also discuss hashing implementation along with problems in this week itself. Okay, so that we will have a plenty of time next week to concentrate only on the nonlinear data structure, that is tree sign graphs. Okay, so that we'll have the plenty of time in the next week to complete these topics, nonlinear data structures. So by this week, I am planning to complete nonlinear data structures fully. Okay, nonlinear data structures along with recursion. Are we clear with the agenda for the week two? Yes. Okay. So let me go ahead and do. Let's start with sorting based algos. Okay. So what is meant by sorting? What is meant by sorting? So major sorting algorithms we have. So basically sorting in the sense if there are numbers are given, like the numbers are given like 100, 5, then 50, or then 11, or then 101, or then some thousand. I need to do what? I need to arrange these numbers, right? I need to arrange these numbers in an order, right? In a specific order. Either it can be ascending order or either it can be descending order, right? I need to arrange these elements or objects what were given. I need to arrange them in ascending order or descending order, right? So I need to arrange them and then I need to perform the operations on that, right? So basically sorting is directly used in programmers, sir. If you ask me, no. You can like sorting is only the problem they will give in the lead code, sir, or in any problem solving, sir. Means no. What you need to do, but if they like means they will not give only the sorting based problem. Based on the sorting, you need to perform the other operation. Means sorting, suppose one problem is given, like you need to sort and then for search the element or search the closest element. Okay. So searching the closest element, suppose the target is given. The target is given like 17 or 18. Okay. So this is asked in campus placements actually from Microsoft. In campus placements, it has been asked. So they are giving some 18. Okay. They are giving some 18 and some 21, 15, 17, 18. Mm, this is 75, you think. And this is some 27. Okay. Now, if you can see this problem, if you can see this problem, you need to find out 18. For this 18, which is closest? So, which is closest to this problem? To this 18, which is closest? What will be the output? The closest comes, you need to find out in the whole array, which is the closest. So, is it the closest is 17, right? The closest is a 17. Okay. So this will be the output. The closest can be, if 17 is not there, the closest can be 21 as well. In the plus 3, the 21 also. The closest can be, if 17 is not there. But here, this since 17 is there, the closest is a 7. The closest is a 21. Okay. So if 17 is not there, the closest is 21. Since 17 is already there, the closest is 17 itself. Okay. So like that, if suppose 21 I am giving, I need to first search whether 21 is there in my array or not. Either how you will search, how you will search whether 21 I wanted to find whether 21 is there or not. How you will be searching? How you will be searching? How many algos were there for searching your for searching, yeah, for searching an array? We have linear search, we have binary search, we have hashing as well, right? Hashing as well, right? So which is efficient here? In this case, which is efficient? Which can be done in big O of constant? Searching can be done in big O of constant. Which is efficient in that case? If the time complex, if the constant is given as big O of 1, it should be done in big O of 1. Then which algorithm you need to use? You should go with the, no, Sriyansh. If you go with the linear, it will be big O of n. Okay. Sumalata, like if you're not interested, you can leave the session and join at 8:30. Okay. Then the attendance will be shared. But don't disturb the class. Okay. Seriously speaking, if you're not interested, just leave and join at 8:30. You will get the attendance link. You will get your attendance. But don't disturb the session. It doesn't mean that like I was not looking at your message. I was looking at your message, but I'm ignoring. But that doesn't mean you need to keep again and again. Okay. Okay. So we were in the discussion. Please don't disturb. Okay. Yeah. So like searching can be done in three ways: linear search, binary search, and hashing. Okay. So hashing is nothing but I can explain you. Give me a moment. Okay. So if you wanted to get in the time complexity in big O of 1, definitely you need to go with the hashing. If the constant is big O of 1 constant, then definitely you need to go with the big O of 1. In this case, which is suitable? Hashing can be suitable. The out of these two, which is suitable? Which is suitable? Binary? How many? 21, it's 75, 17, 18, and 27. The elements are 21, 75, 17, 18, and 27. Hashing is suitable. Okay. The next, only, is binary suitable or not? Binary search is suitable or not? Yes, Anurag, is it suitable? Were they sorted? Or these elements sorted? No, they were not sorted, right? Then how come binary search will be flexible in this case? Binary search will be possible only when you sort it. Only when the input is given in the sorted order. Either it can be descending or either it can be ascending, but the element should be in sorted order, right? In the case of linear search can be sorted also. It is possible unsorted also, right? It is possible unsorted also. Okay. So what is the time complexity of linear search? It will be big O of n, right? Big O of n, right? So in this case, linear search is possible. In this case, hashing is possible. Okay. So what you need to do first, find out the element, whether that element is there or not. For that, you need to check whether it is sorted. So if you are going with the linear search, if you're going with the linear search, it will take big O of n. You need to get sorted, and then you will be finding out the nearest element. Okay. If you are going with the hashing, then you will first insert in the asset. Some asset you will use, you will insert. Okay, you will insert all the elements into the asset, and then you will find out that element. Okay, you'll find out element, like you will mention some true or false, and then you can find out the element. Okay, so means first you need to insert all the elements into the asset. Okay, so what is hashing, if you can answer, if I can tell you. So basically, like I will be doing this code also, but I will give an overview for your sake on the hashing part. So basically, like suppose there are like elements are there like 10, 15, 20, 25, 30. Okay, like this the elements are there. Okay, so what you need to do, like if you there is an asset as table is there. Okay, there is an as table is there. This as table, there will be specific indexes. Okay, there will be specific indexes, and each column, each row, what I am doing here, that is called as bucket. Okay, that is called as bucket. Okay, each bucket can contain single data. Okay, you can only insert single data. Okay, you can only insert the single data, and each bucket will have specific index. That index I can call that as hash index. Okay, so each specific bucket will have hash index. It should not contain more than one data. It should contain only single data. Means if 10 is inserted here, 15 can't be inserted again. In this index, if 10 is inserted, it belongs to 10 only, 15 can't be inserted. So like that, only one type of data we can keep. Okay, one type, which type of data? In the sense, this data only I was talking about, object data basically. Okay, so element in the case of your array, where in the case of your collection, if you're using object data, so each one will have an index. So basically, suppose 0, 1, 2, 3, 4, like that indexes were there. Okay, like that indexes were there, and elements are like this: 10, 11, 12, 10, 22, then 23, then 30. Okay, so like this the elements are there. Okay, I'm taking here only 5. Okay, 5 buckets. Now what will happen, like once you wanted to insert into this hash table, once you wanted to insert into this hash table, what you need to do first, you need to send this object to an hashing formula. Okay, hash formula. Okay, hash formula. Okay, to this hash formula, you should be sending each and every object. Okay, you should be sending each and every object to determine what is the hash index of that particular element, in which bucket it should be kept. Okay, so we don't know, right, in which bucket each element should be kept. So for that reason, we'll be sending each object to the hash formula. In this hash formula, some formula will be setting it up. Okay, generally, like suppose object percentile by number of buckets. Okay, there are like 5 buckets, right? Number of buckets, which is 5. Okay, so if you can see now, like 10 percentile by 5. 10 percentile by 5 is how much? It is 0, right? 0. So it will be moving, the particular 10 will be moving, that object will be moving and sitting at this bucket. Okay, will be sitting at this bucket. Then 11 percentile by 5. How much is 11 percentile by 5? It is 1, right? So 11 will be sitting at here. And then 22 percentile by 5. 22 percentile by 5 is 2, right? So 22 will be sitting here. Then 25 percentile by 5. 25 or 23? 23, right? 23 percentile by 5, which is nothing but 3. Okay. That will be sitting here. Okay. Then you have your 30 percentile by 5. 30 percentile by 5 is how much? 0. And if you can see now, in each index, like all the things were set it up, but this 30 is trying to go and sit it in the same bucket. But what is the condition for us? Each bucket should hold only one data, means nothing but single object it should hold, one value basically, right? But what is happening here? 30 also going into the same hash index. It is giving the same hashing index. Okay, so because of that, it will result in collision. Okay, it will result in collision, hash collision basically. Okay, hash index collision or hash collision. Because of this, it will result in the collision. So this collision can be resolved in two ways, either using rehashing. Okay, rehashing in the sense giving another formula again. So if it is giving like this, if this hash formula is giving this index, okay, if this is resulting in collision, then we will again we will give another formula. Okay, we'll give another formula like object percentile by some 6, some 11 or something like that. I will give another formula. Okay, to resolve this collision, to sit it in a singular bucket, another bucket, if it is doing like that. Otherwise, what I will do, I will form a linked list here. Okay, I will form a linked list here. Okay, so what I will do, I will create a linked list reference here. Okay, linked list means what? Like this, the data will be there, right? So what I will do, I will insert 10 here. Okay, I will insert 11 here. Okay, this linked list I reference, I'll be keeping it to here. Okay, this linked list reference, I will keep it up here, so that it will have only one reference. This bucket will have only one reference, but it will hold 2, 3, 4, 5, 6 something data. Okay, so like that I can resolve the collision using linked list. And that the linked list is like, if the linked list is some size, I don't remember that size currently. If the linked list is of size mm, 18 or something, I guess, the linked list is crossing this size of 18, it will become a, like, I don't remember this size, exact size, but if it is crossing that particular size, if a particular limit of in the linked list, then it will be evaluated automatically to a binary search tree. Okay, to a binary search tree, to a BST. It will evaluate automatically, and the BST reference is kept here. Like that, the implementation is written in the backend. Okay, like this, the implementation is written in the backend. We'll see this implementation while we are doing while we are discussing on the hashing. Okay. Sir, what are what if there are two consecutive same value remainder, but the values are different? How we will hash sort them? Yeah, I explained, right? That is nothing but collision. We'll solve it either using rehashing or linked list or your BST. If the size is the limit has increased, the limit has crossed, then it will automatically evaluate to BST. Like that, we will do that. Mm. Value remainder, but the values are different. We will sort them. Yeah, you understood, right? Okay. Okay. So like this, we will do that. Okay. So basically, this is how the hashing works. Okay. This is asked by someone. Okay. Dot only asked. Okay. So like this, we will go with the hashing. Okay. So here we are going in a sorting, right? Yeah. So basically, sorting, if you can observe here, like will not be given directly the sorting problem, but what will be given, like the sorting should be done, and then particular operation should be done. Then particular operation should be done. So there, my sorting algorithms will be useful. Okay, particular operation will be done. So there, my sorting algorithms will be useful. So if we can consider the major algorithms, we will use mostly your bubble sort. Like the major algorithms used mostly your bubble sort, insertion sort. Okay, over the bubble sort, this is better insertion sort. And then we have our selection sort. Okay, we have our kick sort. Okay, we have our merge sort. Then there are other sortings are also there, like heap sort, bucket sort, like that. Multiple algorithms are there, but the main idea is this or these only. Behind this here also, behind other sorting techniques also, the main idea, they will use another data structure. So in heap sort, they will be going with the heap itself. Here we will be using arrays, right? So these algorithms can be applied. These algorithms can be applied in any data structure. Okay, any data structure you can use bucket sort. If you're going with, they will use hashing as a behind the thing. But the thing is, the main all in all of those sorting algorithms, we will apply the same logic. The logic that is implemented through either of this. Okay, so we have our bubble sort, insertion sort, selection sort, kick sort, and merge sort. Okay, so let's go with the bubble sort. Okay, so bubble sort. So in bubble sort, what we will do means we will sort out the adjacent elements. Okay, we'll start the array from the starting. Okay, from your zero index, and we'll sort out the adjacent elements. Okay, adjacent elements will compare. Okay, adjacent elements will compare, and then we'll sort it up. Okay, adjacent elements will compare, and then we will sort it up over the adjacent elements, so that for every pass, what will happen is, if you're sorting adjacent side by side elements, if you're comparing and then sorting, if you're comparing and then sorting, if you're comparing and then sorting, like this, if you're doing it for every pass, for every iteration. Okay, for every iteration or for every pass, what will happen means, the largest element, if you are sorting in ascending order, the largest element will be sitting at the last. Okay, largest element will be sitting at the last end of your array. Okay, end of your array, largest array at n minus 1. Okay, if you are sorting in descending order, then the smallest element will be at n minus 1. Okay, the basic sorting algorithm, like comparing your adjacent elements. Okay, then after multiple passes, your array will be sorted. Okay, after multiple passes, your array will be sorted. Okay, so let's have an example. Go from here. Okay, let's have an example. Suppose I am taking 15, 23, 7, 9, and 2. Okay, so what we'll be doing, we'll be comparing these both elements. So we are comparing in the ascending order. Okay, so what we will do, if array of if this element is greater than the second element. Okay, if 15 is greater than 21, is it true or false? Zeroth element is greater than the first element, we'll swap it. Okay, so 15 is less than 21 or greater than 21, less than 21, so no swapping will occur, it will be same. Okay, 15 and 23, then 7, 9 and 2. Okay, then again we'll compare this 23 and 7, greater or less than? Greater, right? So what we need to do, we need to swap. 7 will be coming here, 23 will be coming here, 9 will be going here, 2 will be going here. Okay, then we'll compare, then in the next pass, we'll be comparing 23 with 9. Okay, 23 with 9. So what will happen? So 23 is greater than 9. So in that case, we need to swap. So 9, 23, 2. Okay, then we will be comparing 23 with 2. Okay, so 15, 7, 9, it is greater than, so it will be swapping 23. Okay, now if you observe, after the iteration is done, one iteration is done, what is happening? After iterating over all the elements, what is happening? The largest element of all the elements is sitting at the last. Okay, is at your n minus 1 index. Okay, at the end of the year. So this is your pass one. Okay, or iteration one. I is equal to 1. Okay, and then again 15, 7, 9 to 23. Okay, then again we will compare, go from the start. I is equal to 2. Okay, 15 and 7. 15 is greater than 7. So what you need to do, swap 15, 7, 7, 15, 9, 2, and 23. Okay, then again, 15 is compared with 9. Okay, so 15 is greater than 9. So what you need to do is 9, 15, 2, 23. Okay, then again what you need to do, you need to compare 51 and 15. Okay, so 7, 9, 2, 15, and then 23. Okay, okay, and then 15 is compared with 23. No, it is already done, right? This is already done. So 7, 9, 2, 15, and 23. Okay, if you can see now, the second last element will be at the highest position. Okay, and then again we are going to 7, 9 to 15, 23. Again we'll go from starting. So 7 is less than 9 itself, so it will be same. And then 15, 23. Then again, this is again compared. So 7 to 9, 15, 23. Okay, then again this is compared, it is lesser than only. Okay, so 7 to 9, 15, 23. Again this is compared, 7 to 9, 15, 23. So this is using your I is equal to 3. Okay, third iteration, right? This is your third iteration. This is your third iteration. Okay, and then 7 to 9, 15, 23. Okay, I'm writing up here 7 to 9, 15, 23. Is the array sorted now? Sorted or not sorted? sorted, not sorted, right? Still. So it will move to the next iteration, that is I is equal to 4, compared, right? So 2 will be coming here, then 9, 15, 23. Okay. Then again, this is compared. So it is already sorted. Then 7, 9, 15, 23. I will write it off first. So if you can see, 2, 7, 9, 15, 23, 2, 7, 9, 15, 23. Okay. Now if you can see here, or we can see here, in four passes, the array is sorted, right? So you have your five elements. In five, you have your five elements, and in how many iterations the array is sorted? In four iterations, right? So can I consider it as in n minus one iterations the array is sorted? Yes, in n minus one iterations the array is sorted. Yes. So many times the loop should run, because the last one is at the last position, right? Means if you can see here, so in four iterations the array is sorted, and if you can see also here, the last element is here. Okay, the last element is here. So I is going from 0 to 3 to get it done. Okay, and then we have our and if you can see here also 15 and 23. See, these are all sorted. So like let me write the loop. So for loop will be running for how many times? Outer for loop is nothing but iterations, right? So I is equal to 1, I less than or equal to n minus 1. Why it is doing like this? N minus 1. Okay, n minus 1, and then I plus plus. Okay, for I is equal to 1, I less than or equal to n minus 1, then I plus plus, right? I plus plus. And then inner loop will also be running for, so see how many iterations were there? How many iterations were there? So for each loop, how many iterations were there inner loop? So how many comparisons were there? Comparison is for your inner loop, right? So 1, 2, 3, 4. Here also, if you can see, in second iteration also, you have 1, 2, 3, like 1, 1, 2, 3, 4. Here also 1, 2, 3, 4. And here also 1, 2, 3, 4. Means how many iterations you are getting it up? 5 elements, 4 iterations, right? 5 elements, 4 iterations. So j is equal to 1, j less than or equal to n minus 1, okay, j plus plus. Then what I need to do? I should check whether a of I greater than array of j. Okay, array of j. If it is greater than, what I need to do? I need to swap. How should you swap? So you'll be taking some temporary variable. A of I will be putting up here, and then a of I is equal to a of j. A of j is equal to temp. A of j is equal to temp. So this is how you swap. Okay. So what is the time complexity of this? What is the time complexity of this? N minus 1 into n minus 1, right? So outer loop will be running for n minus 1, inner loop will be running for n minus 1. We go off n power n square, right? So, is this algorithm efficient? Is this algorithm efficient? Can you tell me, is this sufficient? What is happening here? Here am I doing all the comparisons. See, in the last pass, what I am doing, I'm not even I'm not like there is no swapping happening, but just I'm comparing. See, 1, 2, 3, right? So I was taking 1, 2, and 3, three iterations more. The array is already sorted in the first iteration itself, but I was taking 3 iterations more, right? So many iterations are wasted here. 3 iterations were wasted. Okay. Here you see, here in the third iteration, until this point the array is sorted, right? Until this point only the array is sorted. But what I am doing, I'm again comparing these two iterations. How many iterations are wasted? Two iterations are wasted here, right? Then here you have how many iterations? One, like you have here, this is already sorted, no need to compare, right? This is already sorted, the last element, the last two elements. So many iterations are wasted, one iteration is wasted. Yes or no? One iteration is wasted because anyways the last element will be sorted. Anyways the last element will be sorted. You need not to compare this one as well because anyways this will be sorted anyways because in the second iteration this will be the second largest element, right? So no, you no need to compare this one, right? Here also anyways until this point you can skip it up, means how many iterations, one and two, right? Here also you can skip until this point, right? Until this point. So 1, 2, and 3. Okay. Now tell me how can I edit this? How can I edit this? So when I is equal to 1, how many iterations were needed for me? How many iterations were needed for me? 4 iterations were needed. When I is equal to 1, 4 iterations. Okay. When I is equal to 2, how many iterations were needed? 3 iterations. When I is equal to 3, 2 iterations. When I is equal to 4, only one iteration is needed for me, right? So can you tell me how can I edit this now? So someone has asked to share the feedback. Soumya, can you tell me how can I edit this? Soumya, are you there in the session? Can you tell me how can I edit this? I've written like this, but I don't need to write like this, right? I can minimize my iterations. How can I edit this? Can you tell me what is the condition I should be keeping up? Soumya. So what condition I should be writing, guys? So I need to decrease these iterations, right? I should be decreasing these iterations. So 1, it should run for 4, like 2, it should run for 3, 3, it should run for 2, and 4, it should run for one time itself. So any logic here? Any logic here? How much time it should run? The inner loop should run for how many times? So basically n minus I, right? So basically this inner loop should run for n minus I. So basically 1. So when one like number of elements is 5, right? 5 minus 1. 5 minus 1, which is nothing but 4, right? It should be running for 5 minus 1, which is nothing but 4, and then 2. 2 is nothing but 5 minus 2, which is nothing but 3, right? 5 minus 3, which is nothing but 2. So it should be running for n minus I times. The inner loop should be running for n minus I times. I is equal to 1, j is equal to 1, j less than or equal to n minus I times. Correct, guys. Correct. Correct, Anurag. Okay. So the inner loop I modified to n minus I times. Is it efficient now? Is it efficient now? At this point, it's okay. Is it okay? So does every element, suppose there are 10 elements, I'm minimizing iterations, that's fine. Okay, within the iteration, I'm minimizing iterations. But can you tell me like everything will be sorted in four iterations only? Or 4 iterations on n minus 1 iterations only, everything will be sorted. Suppose there are like elements are there. Suppose the array is already sorted. Okay, suppose the element is like this. Okay, 11 and then 10. Okay, and then 10. Mhm. Okay, 12, 13, 14, 15, 16. Okay, there are like 1, 2, 3, 4, 5, 6, 7. 7 elements are there here. Okay, 7 elements are there. Uh, how many passes are required for to get this sorted? How many iterations are required? Only one iteration, right? I don't require the other iterations also, because see, in the first pass, I is equal to 1. You will run for how many times? You will run for n minus I times, right? N minus I times in the sense 1, 2, 3, 4, 5, 6, 7, 7 minus 1, which is nothing but 6 inner iterations will run. J will run for 6 times. Okay, but the thing is, if you can see here in the first pass itself, the array is sorted, and what you will do, you will compare, move on comparing, right? What you will compare, like you will compare each and every element now again, according to your algorithm. Is it optimized still? Is it optimized still according to your n minus I iterations? Is it optimized still? Now, how many times it will run now? I n minus 1 in the sense it will run for 6 times. This iteration, the same thing. It is already sorted, but it is running for 6 times more. 6 times more along with these iterations. 6, 5, 4, 3, 2, 1. Those inner iterations as well. It's taking time, right? So how can I optimize still? How can I optimize still? So I will check in every iteration. I will check if the swapping is happening or not. Okay. Suppose here swapping is happening. Okay. In every, like suppose in the second iteration in the j is equal to 1, the swap has happened. That's fine for me. If the swapping is happening in that particular iteration, that's fine for me. Okay. But if suppose in the second iteration also the swapping is happening, but in the third iteration the swapping is not happening. In the third iteration the swapping is not happening. In that case, what I will do, I will not go to the fourth iteration. I will not go to the fourth iteration. I will simply end the loop. I will simply end the I block. Okay, I will simply break out from the I block. Okay, if the swapping is not happening, I will check on the swaps whether it is happening or not in that particular iteration. If the swapping is not happening, if the swapping is not happening in the third iteration, I will break it up here itself. I will not go to the fourth iteration. Okay, so like that I can optimize. So what I will do, I will use one flag. Okay, some swap flag, I can use it up here. So flag is initially false. Okay, flag is initially false. Okay, so for everything I will make it as false itself. If the swapping is
It's
happening,
8
I will
o'clock.
make that as true. Okay, I'll make that swap as true. I'll make that flag as true. Okay, the swapping is happening, and then I will check it up here itself. Okay, before going to the next iteration only, I will check if flag means if swap has not happened, flag double equal to false. Then what I will be doing, just break that loop. Just break the outer loop itself. Okay, so means now what will happen? See here, until this point the swap has happened third uh, until third, fourth. Okay, if you see this example, until in the first iteration the swap will happen, the flag will be true, and it will move to the second iteration. In the second iteration the swap has not happened. The swap has not happened. In that case, what will happen? In the second iteration itself my loop will stop. In the second iteration itself my loop will stop. Means in the second iteration I'm checking whether any element is again swapped or not. In the rest of the array, if any element is another swap or not, I will check. Okay, if the flag is false itself, I will break that loop. Okay, Okay, how 10, 11, 12, 15, 17, 0, 1. Yes. So how many swaps it will require? How many iterations it will require? So here you're giving the example as 10, 11, 12, 15, 17, 0, 1. Okay. So no swapping is required. Here also no swapping is required. Here also no swapping is required. Here also no swapping is required. But here swapping is required. Right? So 0 will come here, 17 will come here, then 1 will come here. Then again swapping is required. So 0, 1 and 17. 0, 1 and 17. Here it will be 15, 12, 11 and 10. This will be your I is equal to first iteration. Okay. This is 1, right? 1. Okay. So then I is equal to 2. Again it will compare. Again it will compare. Okay. So again it will be comparing, but the max time is big of n square only it will come, because we are calculating the worst case, right? Worst case, like this is some of the best case only. This is some of the best case one, but in the worst case every element is unsorted only, we'll think. So in that case the maximum timeline of this algorithm is n square itself. Okay. But we need to complete in less through bubble sort, through adjacent sorting. Maximum will take it as n square itself. Okay. It will be in the best case when that is already the swaps are less. The swaps are less, then the iterations will be less. Then it is the best case only. But in the worst case, if I include the algorithm, how big O complexity, big O terms, we will find out the worst case only, right? In this case. So worst case, the time complexity is big O of n square itself. Okay. So can you do this problem fast? I'll be giving 5 minutes of time. Can you try this out? You can take one input in the array, like this input only, you can take it up and try to do this, implement this algorithm in any editor that you wish to. If you wanted to go with the lead code also, you can search for that problem lead code, bubble sort, and you can do it up. Otherwise, in your own editor, either it can be online editor or Eclipse editor, anywhere. Let's take an array as input. Array I will be taking in Java. I wanted to do this, implement this algorithm. Array I will be taking some initializing array, you can take it up. Okay. So you can take all these inputs 2 comma 7 comma 9 comma 15 and then 23, and then you can write down this algorithm. Okay, you can do this algorithm, and once done let me know. Once done let me know in the chat box. If there are any doubts in still in bubble sort, you can ask me in the chat box. Otherwise do this code and then put done in the chat box. Okay, I should get maximum dones in the chat box. Means don't put only done. Do that and then do done. Be honest to yourself. This is an online session. I cannot check whether you are doing or not, because I don't know where you are sitting or whether you are sitting with a laptop or not. I don't know. Right? The responsibility is on you to complete by yourself. You should be honest to yourself. Okay. At any point of time in life, if you wanted to move forward, then definitely our honesty only matters. Okay, we need to be honest. If we are honest to ourselves, to myself, if I am honest, then I will move forward. Otherwise I will be step like stopping there itself. If you wanted to move forward in life, definitely honesty is required. Okay, so please do the code and then put done in the chat box. Not done, everyone. Like I'm not seeing any messages in the chat box has done. Anyone has done? Code. Okay, okay. I will write the code as well. No issues. Okay, I am taking another class here. Okay, I'm taking my main method. Okay, I'm taking an array. And the array is equal to what are our elements? 279, 15, 23, 7, 9, 2. 15, 23, 7, 9, and 2. Okay. So I'll be initially what I thought to do. I'll be taking a outer loop that is I, which will be running from I less than or equal to I minus array dot length, right? So what I will do, I will put this array dot length into n array dot length I less than or equal to n I plus plus. Okay. Then what I will be doing, I'll be taking another loop int j is equal to, like I will be writing the loop from 1. Okay. So j less than or equal to n minus 1, right? Here also n minus 1 j plus plus. Okay. So what I am doing, I'm just doing a simple comparison. If array of I greater than array of j, then what you need to do, you need to swap, right? So what you need to do, int temp is equal to array of I, you'll be putting it there. You will hold it in the temp variable, and then you will put array of j in array of I. Means you'll be putting this like you'll be putting this 7 in 23. Okay, already this 23 is in temp. Okay, and then what you are doing, array of j is equal to temp. Okay, you are putting this 23 here at this position, you're putting the 23. So this is how you're doing the sorting until n minus 1. Okay, let me, okay, int a, I'm using a for each loop. This will be useful for your arrays as well as collections. Okay, sys out of, yeah. Okay, I'm running this now. Array of, okay, I'm printing a, I should print a. Okay, what it is telling. Okay, so 15, 23, 9, 7 is not sorted. Why? This is happening 15, 23. Okay, area of J. Where I am using J, where I should change? I made any mistake here. At which line you are telling, Anurag? Okay, okay. I was comparing that way. Sorry. I need to compare adjacent elements, right? Yes. If area of J greater than area of J plus 1. Okay, I should be comparing adjacent elements. Very sorry for that. Okay, it should run for, it should be until less than n minus 1 itself. Okay. Less than n minus 1 itself. Okay, let me check. Yeah, sure. Area of I, area of J plus 1 is equal to 10. Nine, 7, 23, and then 7, right? 15, 2, and 23, and then 7. That is that is 7. So into J is equal to 1 and J less than or equal to n minus 1. And then J plus plus area of J greater than J plus 1. Then I am doing this area of I is equal to, okay, between area of J. Area of J. N minus, like I was doing for n minus 1 actually. Startingly, I was implementing for n minus 1 itself. Okay. So the loop should run from 1, 2, 3, and then 4, right? So 4 in the sense it should be n minus I, right? N minus 1 itself. Okay. So I was implementing starting for the n minus 1 itself. Okay. So it is j greater than j plus 1 and then I am swapping it up. Okay. Okay, let me implement the whole solution. And flag is equal false. Okay. Okay. I should be breaking it. Okay. Okay. This should be running for n minus I am doing it up. Then I will check. Okay. Index can be started from 1 now. Okay, index can be okay. Since I was comparing zeroth element, okay, array of j I was comparing, right? Array of j, yes, yes, correct. So I should start the loop from 0, right? And then this one you can do it anyway. And then j less than or equal to n minus I, j less than or equal to n minus I itself you can keep. Okay, I think it is working. So if the index is starting from 0, then you should go until -1 also, right? Yes, if you are considering index as 0, then it should go until -1 and then you should be subtracting the I, right? Let me check if this is running, right? So if the index is starting from 0, that is the issue I have kept it up here. So index should start from your 0. I was starting from 1. Okay. So you should compare the first element also, right? Since you are comparing the adjacent elements, you should be comparing the first element as well. Okay. And then the loop should run until your -1. Okay. The loop should be running until -1 since you are starting from 0. And then you are subtracting the iterations. Okay, you are separating the iterations. Let me remove this so that it will work now. It is going to the n minus 1. Let me check. Yes, it's working. Okay. So before I was doing a wrong mistake. That is, I was starting the loop from 1. It should be from 0 because I should compare the adjacent elements. Okay, I should be comparing the adjacent elements. So index should be starting from 0. Okay, that is a mistake I have done. Okay, these are all optimizations. It will not lead to a solution. These are all optimizations, but the loop should be running from, the outer loop will run for basically n minus 1, whereas inner loop will run for n minus 1. In that, what we are doing, we are minimizing the swaps. We are minimizing these iterations using this flag variable. Okay, and then what we are doing, we are minimizing the inner iterations as well. Inner iterations also, we are minimizing using the n minus I minus 1 condition. Okay, so this is how bubble sort will work. Okay, less than or equal to n minus I minus 1. Okay, so basically n minus I, when I'm starting the loop from 0, I was going until less than or equal to if I'm putting. If you are telling n minus I also you can run, but I should be removing this equal to, that's it. Okay, otherwise it will lead to the array index out of bounds condition. Okay, I less than array dot length to -1 and then array dot length -1. You're putting -1 before, see your condition n minus 1 minus I you're doing. So it is I is 1. What will happen? If you're doing like this, 5 minus 1, 5 minus 1 minus 1, if you're doing, how much it will be? 4 minus 1, which is nothing but 3. It will run for only 3 iterations. Inner loop will be running for only 3 iterations in that case. So the first array, the first iteration should run for maximum 4 times, n minus 1 times, right? N minus I times. So basically n minus 1 times it should run. The first iteration should run basically for 4 elements. So if you can see here, it should run until this point, right? It should run until this point, right? So for that reason, you should not be keeping n minus, it should run for 4 times. So means nothing but n minus I. Okay, n minus I times it should run. N minus I, and then when you are starting the loop from 0, So it should be running until n minus I minus 1 times, n minus I minus 1 times. Okay, you're Anurag, you're putting the loop as n minus 1 minus I. Yes, 0 to 3 in the sense, basically the largest element will be at the in the starting iteration. What will happen? The largest element will be at the end. So you need not to compare 15 with 23 in the second iteration, right? So in the anyways this will be at the last end itself, right? So at this position only. So if you can see here what is happening here, 792. If you can see this, yeah. So here you can see this iteration is not needed. This iteration is not needed basically. 2 and 23 comparing is not needed. That you can skip it up. How you can skip it up? N minus 1 times you are running here. Here these two iterations can be skipped. For that you are using n minus I, right? We have discussed that, right? Okay. So you need to change this. N minus I minus 1. You have written it as n minus 1 minus I. Okay. Next one. Here a flag also, you check on the flag as well. Flag variable also check. You try on your code, you will understand. You try on your code. Suppose you're not getting anything, like if you're not getting in sorting or any problem, you're not getting to loops or anywhere. Just try run the code with your input. Okay, each and everything you try it on it. So what you need to do, first I is equal to 1. Debug it. I is equal to 1 initially. And then you go inside. Here flag is false. So flag is false. Like that, you use the comments and then you need to try run. You need to debug it. So what you need to do, then j is equal to 0. Then j is equal to 0. And then j less than or equal to n minus I minus 1. You should check this condition. J less than, like 0 less than n minus I minus 1, which is nothing but n is nothing but 5. 5 minus I. 5 minus I, which is 5 minus 1. 1 minus 1, which is nothing but 4. Okay, 0 less than 4. Condition is true. You should go inside and then you should be checking 15 greater than 23 or not. Like that, you should check each and everything. If you check, then you will find out where the error is. Okay, you try run your code. The next one, we will go with the insertion sort. Okay, we will go with the insertion sort. Where is my pen now? Okay, insertion sort. So let me take some 16, 14, 5, 7, 9. Okay. So in the case of your insertion sort, in the case of your insertion sort, what you need to do, in the case of your insertion sort, what you need to do, basically in the bubble sort, you are comparing adjacent elements. Okay. In the case of your insertion sort, you will divide this into two parts. Okay. You will divide the array into two parts. You will consider the first part of the array as unsorted. Okay. The second part of the array is sorted. Okay. Why is my mind doing like this today? The first one is already sorted. The second one is the second part is unsorted. Okay. You will think the first element of the array is unsorted, whereas the second element of the array is unsorted. Okay. Then what you will be doing? you will be each and every element you will compare with the sorted array where to place it. Okay, so first what you'll be doing, you will divide the array into two parts. Divide the array two parts, sorted and unsorted. Sorted is array of 0. Okay, array of 0, whereas unsorted is remaining array. Okay, remaining array. And then what you will do, you will push this element, the first element of that unsorted array, you will take it up, you will place it up inside a temporary array. You will place it up inside a temporary array. And then what you will be doing, you will compare this temp, you will compare this temp, you will compare this temp with the unsorted array, the last element basically. Okay, so you'll compare this temp with 14. So 14 is less than 16 or greater than 16. So when temp is less than array of 0. Okay, basically the before element you will compare. Okay, when this 14 is lesser than 16, what you will do, you will move this 16 to the one position right. Okay, so what will happen now? Here the 16 will be coming here in the place of 14, and then 5, 7, 8. Whatever is there in the sorted array, that will move to the left. That will move to the right, basically. Okay, then immediately you will not place it up here. This tempo value will not swap. This is not kind of swapping. Okay, you will check again. Previously, any elements are there to compare again. If they are not there only, then you will place it up this one at the this tempo value at here. Okay, so this is your first iteration. This is your first iteration. Okay, okay, and then what you are doing, then again in the second iteration, you will think this as sorted, you will think this as sorted, this as unsorted, this as unsorted. Okay, then again what you need to do, you need to, the first element of the unsorted array should be placed within the temp variable, should be placed within the temp variable, and then you will be comparing this with this temp variable. You will be comparing with the last element of the sorted array first. So 5 is less than 16 or greater than 16? 5 is less than 16 or greater than 16? Less than, right? If it is less than, what you'll be doing, you will move this element, you will move this element to the front. Okay, you'll move this element to the right by one position. So 16, 7, 9. Okay, then you will not place immediately this element at here. Okay, you will not place immediately this element at here. If you're placing like that, it will become a swapping. Okay, you're not doing swapping here. Okay, so you will compare what is the previous element again. You will compare with this element also in the sorted here. 5 is less than 14 or greater than 14? Less than 14. So what you need to do? You need to push this element to the right. We'll push this element to the right. Okay, so what will happen? 14 will be coming here, then 16, then 7 and 9. Then again you will compare if there are any elements out there or not. There are no elements, so this is the correct position. So you'll put that 5 here. So what will happen? 5, 14, 16, 7, 9. Okay, now what will happen? So this is your, now you will consider, now again what will happen in the I is equal to third iteration, you will take the next iteration, you will go, then 16, 7, 9. Okay, so you will consider this as your sorted now, this as your sorted now, this as your unsorted. Okay, then what you should be doing, you will take the first element of the sorted array. You will be placing inside the temp. You will be placing it inside the temp 7. Okay. You will be placing inside the temp, and then you will compare this temp element with the first element in the sorted array. Okay, the last element in the sorted array basically. 7 is less than 16 or greater than 16? Can I get a quick heads up in the chat box? What you need to do if it is less than? If it is less than, what you need to do? You should be shifting it to the right by one position, right? So 16 and then 9 to a temp position. Okay, and then you'll be placing immediately 7 here. At that position, you will place it up. What you will do? You will compare with the previous element again. Okay, so 7, I'm comparing with the 14. Less than or greater than? Less than. So I'll be shifting to the right. 16, 9. Okay, then again the 7 is compared with, you'll be placing immediately here. No, I will compare with the 5. It is greater than. It is greater than. So then what you need to do, you should place that element at that particular position. This is the correct position. Okay, 14, 16, 9. You'll be placing the temp at that particular position if it is greater than. If it is greater than, you'll be placing at that particular position. Okay. Now this is your array at the I is equal to third pass. Then I is equal to 4, 5, 7, 14, 16, 9. Okay, 5, 7, 14, 16, 9. In this, which is greater? Like in this, until this point, I will consider it as sorted. This as unsorted. Now what you need to do? You will be placing this element in the temp. That is 9. Okay. Then you will compare with the previous element. Okay, it'll go in this order. Okay. So 9 is compared with 16. 9 is less than 16 or greater than 16? Temp you need to compare with the previous element. Temp is less than 16 or greater than 16? Less than 16. What do you need to do? We will be moving this 16 to 9. Okay. Then again, you'll be placing immediately here? No, you'll compare with the previous element again. Okay, previous element again. 9 is compared with 14. Greater than, less than? Less than. If it is less than, what you need to do? You will push this position to the right. Okay. Then again, you will compare this 9 with 7. Is this less than or greater than? 9 is less than 7 or greater than 7? Greater than. If it is greater than, you will put that 9 at that particular position. Okay. So basically the condition is if temp is less than array of like previous element basically. Okay. Array of I minus 1. Okay. Then what you need to do? You should move that element to the front. Okay. You should move that element to the front. So basically what you'll be doing, array of I is equal to array of I minus 1. Okay. Else what you'll be doing? Else what you'll be doing? Temp is equal to array of I. Oh no, no. Array of I is equal to temp. Array of I is equal to temp. Okay. You will decrement the I value. You will decrement the I value minus minus. Okay. These are the two conditions you need to follow. Okay. So you got the algorithm, right? You got the algorithm, right? How it works, insertion sort. So basically in insertion sort, what we are doing, we are dividing the array into two parts, sorted and unsorted. And we are picking each and every element from the unsorted array. And we are putting that element, we are inserting that element in the sorted list. Okay, we are inserting this 9 element in the sorted list at the appropriate position. We are not doing swapping here. We are inserting, we are picking each and every element from the unsorted list, and we are putting it in the sorted list at the appropriate position. Okay, at the appropriate position, we are adjusting that element or putting that element. Okay, that is how insertion sort works. Okay, so if I write an algorithm, how many loops are required here? How many loops are required here? If I write an algorithm, how many loops are required here? How many loops? Two loops, right? So here also we require two loops. One for moving front, one for moving in the front direction. The second loop is for moving in the sorted list, backward direction, right? So what I need to do for int I is equal to int I is equal to where I need to start the loop, where I need to start the loop. I should be starting from the zeroth position or first position. I should be starting from the first position, right? So int I is equal to 1, I less than or equal to n. Okay, I less than or equal to n I plus plus. Okay, int I is equal to 1, I less than I less than n itself. Okay, I less than n and then I plus plus. Okay, and then I'll be taking the temporary array, temporary element. I'll be putting it in the temp array of I. Okay, array of I. Okay, then what I'll be doing? Then what I'll be doing? I need a second loop, right? I need to move it in the backward direction for second loop. So what I'll be doing, j is equal to, I'll be taking a j variable into j is equal to I minus 1. Okay, I minus 1 while I need to check the condition while j greater than or equal to 0. Okay, while j greater than or equal to 0. Okay, if it is greater than or equal to 0 only, I should be moving forward, right? I should be within the while loop. Okay, means if it is at the end position like this, if it is at the end position, if there are no elements before it, then I should not be moving backward again, right? That is a condition. And I will be comparing, I will be comparing array of array of I'll be comparing temp is less than array of j. Temp is less than array of j. Then what I need to do, if these both conditions are true, then what I need to do, I'll be putting array of j. I'll be putting at that particular position. So array of j is at, so nothing but array of j plus 1 is equal to array of j. Okay, array of j. Okay, array of j plus 1 is equal to array of j, and then I'll be decrementing the I'll be decrementing the I'll be decrementing the j value. Okay, I'll be decrementing the j value. So first I'll be taking temporary, and then I'll be decrementing the j value, and then inside the loop I will again decrement. I will move in the backward direction until j greater than or equal to 0 and until temp less than or equal to a of j. If it is greater than or it has reached the end of the loop, then what I need to do, I need to place temp at the I need to place temp at the jth position. Okay, a of j is equal to temp. Basically I need to place it at j plus 1 position, because see, anyways this will be minus 1, right? If it is reached the end of the loop, then it will be minus 1, right? So I'll be placing at the j plus 1 position. A of j plus 1 is equal to temp. Okay, so this is how it will work. So I will be taking a for loop, two for loops, one for going in the forward direction, one for going in the backward direction. So for I is equal to 1, I less than or I less than n, I j plus plus. Okay. So this loop will run for how many times? Basically, I less than n. So basically 1. So if you see the first one, I'm running the loop from 1. 1, 2, 3, 4. Okay. So basically 1, 2, and then 3. Okay. So it should run until this point, right? I less than or I less than n, right? So and then inner loop I'll be taking for temp. Temp I'll be taking at the first element, and then I'll be taking a j variable for moving in the backward direction. Okay, while j greater than or equal to 0 and temp is less than a of j, what I need to do, I need to move the element one step to the right. I need to move the element one step to the right, and then what I am doing, I was decrementing that j. Okay, and then when these conditions are false, I should place the j element at the temp. Are we clear? Yes. Yes. Okay. Let me quickly execute this as well in the coda. 579 16 14 579. Five, 4, 3, 2, 5, 7, 9. Okay. I will be running a loop now. So int I is equal to, I will be running the loop from 1. Okay. Since I need to start the loop from here. Okay. I less than n. I less than n in the sense I less than n minus 1. Okay. So basically 1, 2, 3, and 4. Okay. Then I plus plus. Then what I'll be doing, I'll be taking a temporary variable into temp is equal to, I'll be putting this 14. I'll be putting this 14. I'll be putting that 14 in the temp. Okay. A of I. Okay. And then what I am doing, while I was decrementing that loop as well, I is equal to into j is equal to I minus 1, and then I'll be taking a value j greater than or equal to 0, and what I need to check, I should check while a of j like r temp less than a of j. If either of the condition, if both of the conditions are true only, then what I'll be doing, I will be moving a of j plus 1 is equal to a of j. Okay, a of j plus 1 is equal to a of j. Then decrement your j value. Okay, and then if none of the, if it has reached the end of the array, it has reached the end of the array, or when it is greater than, what I need to do at that position, I will be putting that a of at the jth position. Okay, a of j plus 1 is equal to temp. Okay, a of j plus 1 is equal to temp. So I less than, I'll be taking a dot length. Okay, and then I'll be taking the for loop to print it. Enter B colon A. Paste this out. B. Okay, let me run it. Okay, 579 49 60. So like this, it is going to done. Okay, are you clear? Attendance link is already shared in the top. Okay, Anurag, got that? Anyone has any doubts still? Okay. Okay. So let me, anyone has any doubts? Still I'm waiting. For 1 minute, I will wait it up. Yeah, they will disturb because all will be not same, right? Some will have interest. So in your offline class also same, right? Some will listen, some will not listen. In the same way applies to even up online class. So it depends upon. So in offline class, I can control it directly. I can go ahead and control. But in an online class, how can I control? I cannot see their faces also, right? So definitely it will be there. But the thing is only one, I said, right? Honesty matters. So what we are learning when we join the session, what we learn, or where you should go from here, that should matter because attendance today it will be present, tomorrow it will be absent if you're not joining. But the knowledge remains same, right? If you're getting today knowledge, some sorting algorithm you have learned today, that will be there for the life. Like like many interviews you can attend. If you have understood this one, in any interview they ask also some 10 12 interviews they ask this question also, you'll be able to do. And based on this, you can apply this on many problems as well. The same sorting technique you can apply in many problems, and if you know which is efficient, then you can do that well. You can do that in few fraction of minutes itself, right? But when we compare a listening student and with a non-listening student who is concentrated only on attendance, he will take so much of time to do that problem, or he will not do also, right? So like that it will be if you learn and if you don't learn. Okay, that's fine. Uh, okay, so today what I am doing, like I have discussed the insertion sort and your bubble sort, right? Let me go ahead and discuss fastly the selection sort as well. The selection sort as well. So that tomorrow I will go with the other sorting techniques. Okay. So selection sort, if you can see, I will take the same input 16, 14, 5, 7, 9. 16, 14, 5, 7, and 9. Okay. So in the selection sort, in the insertion sort, what you have did, you have taken this as sorted, this as unsorted, right? In the case of your, it is unsorted, right? In the case of your insertion sort. In the so selection sort, in the case of your selection sort, you will take 16, 14, 5, 7, 9. This has unsorted, this has sorted already, and you will take this whole array as unsorted. This whole array as unsorted you will take, and what is there before that as sorted. Okay. So you will take whole array as basically unsorted, and then what you will do, you'll find out the minimum element. You'll find out the minimum element of of all this. Okay, you will compare the first, like you will compare basically nothing is there here. Okay, nothing is there here. Then you will compare what is the minimum element. Minimum element is 5, right? So what you'll be doing, you'll pushing this 5 at the front position. You'll swap this 5 at the front position. So now what will happen? 5 will be coming here, 14 will be coming here, 16 will be coming here, 7 will be coming here, 9 will be coming here. Okay. Then now what you will take in the second iteration, I is equal to 2. You will take this as sorted, this as unsorted. Then in the unsorted array only, you will not touch sorted in this case. You will just find out the minimum element here. What is the minimum element? It is 7, right? It is 7. So you'll be pushing this 7 to the first position of the unsorted array. You'll swap it with the first position of the unsorted array. So 7 will be coming here, 16 will be going here, 14 will be coming here, 9 will be coming here. Now in the third iteration, this is sorted, this is unsorted. Okay. Again, you will find out the minimum element. What is the minimum element? Can I get a kick heads up in the chat box? What is the minimum element? It is 9. What you need to do? It is 9, right? What you need to do? This 9, you will be swapping with this one 7. Huh? You will be swapping with 7, or which position you will swap? 7 or 5? Swap it with 16. Okay, swap it with first element in the unsorted array. So 5, 7, 9, 14, and then 16. Okay, this will be going here. This will be coming here. This is your I is equal to fourth iteration. In the fourth iteration, 4 elements will be 4 element, like 4, 5, 7, 9, right? Yeah, yes. So until this point, I minus 1, which is nothing but 3 elements will be sorted, and this is unsorted. Now, what is the minimum element? Minimum element is at the first position itself. So no need of swapping. Then you will go to the, you will go to the, anyways, this will be sorted only, right? So you'll run the loop until, I is equal to 4 iterations. Okay, I is equal to 4. If there are 5 elements and minus 1 iterations. Okay, in every iteration, you will find out the minimum element of the unsorted list. And then you will, like, what you need to do? First, you will run the loop from 0 itself, right? You will run the loop, the outer loop from 0 itself until n minus 1. Okay, and then in this, you will find out the minimum element. Okay, you'll find out the minimum element. Then you will swap this minimum element with the first position, that is array of I. You will swap it up in the whole array. What is the minimum element? You will swap it up with the array of I. Okay, array of I. And then you will iterate. You will iterate forward. You will iterate forward. Okay. So I will not write the algorithm for this. This will be the assignment for today. Okay. Implement this in code. Okay. Implement this in code. You understood the algorithm, right? You understood the algorithm, how it works, right? Working. Yes. Please implement this in code. This will be the assignment for today. Okay. Selection sort will be the assignment for today. And if suppose if you have not done the problems of the weekend, the 3 problems, please try doing that as well. The 3 problems, if you are not done over the weekend, do that as well. And then one will be selection sort. Okay, and then
It's
you
9
can
o'clock.
practice other sorting in you can put the filter as sorting, and you can practice in the lead code. Okay. Okay, so the notes is already shared, Kajal. Okay, in the notes you'll be able to find the assignment questions as well. Okay, so on that note, thank you so much, guys. We'll meet again tomorrow at 7. Okay, yeah, thank you, guys, and good night.
Yeah, thank you, sir. Thank you so much. Good night.
Yeah, thank you, Sushmita.
Yeah, so dear students, thank you all for joining. We'll wind up for the day. Good night.